Hello guys, today we're gonna talk about exponential versus linear growth. So we'll be solving the problems from 1 to 8, only 8 problems. So I hope it will be not that difficult. Okay, let's take a look. Okay, if the initial population of rats was 20 and grew to 25 after the second year, which of the following functions best model the population of rats P with respect to the number of years T if the population growth of rats is considered to be exponential? Well, first of all, let me write the formulas for linear function and exponential function. So let's say that we have a linear growth. We know that the linear growth can be written as y equal to mx plus b. So this is our usual linear function, standard form, whereas exponential growth or decay can be written as y equals to a times 1 plus rate divided by 100 to the power of t. Okay, so we can just take a look at that. D and A, they most likely look like linear growth. So you can see 5t plus 20, where 5 is basically m. This is our slope. And in this case, we have 5t squared. When we have a t squared, it means that we have quadratics. But they're asking us the exponential function. So which one is the answer? What, it's C or B? Well, it says that the initial population was 20. And if you remember, from this formula, A is initial value, R is rate, and T is time. So basically, if you have y equal to 21 plus, in this case, the the first year value was 20 and it rose to 25. Then it rose to 25%. 25% of 20 is just basically 5. So 20 plus 5 is 25, meaning that in this case, 1 plus rate was 25 over 100 to the power of t. And if you write that down, that's going to be y equal to 21.25 to the power of t. And that is exactly why our answer is B. Okay. Let's look at number 2. If the initial population of pandas was 100 and grew to 125 after the first year, which of the following functions best models the population of pandas? P with respect to the number of years, T if the population growth of pandas is considered to be linear. So if you look at this linear growth, we have mx plus b. But if you look at these, all the functions, so you have quadratic here. This is not our answer because, as I said, it is quadratic function. In this case, we have exponential. In this case, we have exponential. So by the method of elimination, that you can find that the answer is A. But if you were to actually solve it, so we know that y equals to mx plus b. M is our slope, and slope is basically our rate, the speed with which it is increasing or decreasing, where b is initial value. So in this case, the number of pandas was 100. So in this case, B is equal to 100. The rate, or M in this case, so let me write it as M, is 25. Why? Because in the first year it was 100. In the second year it became 125. So it is an increase of 25 units. That's why the answer is A. Let's look at number 3. It says the population of trees in the forest has been decreasing by 6% every 4 years. The population at the beginning of 2015 was estimated to be 14,000. If P represents the population of trees T years after 2015, which of the following equations gives the population of trees over time? Okay, well, we know that it is an exponential function because we have a decrease of 6% every 4 years. So we can write it as y equal to the initial value, 14,000. 1 minus, we don't have a plus here because it is a decreasing exponential function. In this case, we need to divide rate by 100. So we have 100 here, and the rate is what? 6%. And in this case, we don't just put t. Why? Because we have a decrease of 6% every 4 years, meaning that if we were to calculate for year 1, we would have to divide 1 by 4. Because we need to understand, so let me explain in different words. So the growth is in every 4 years, and the way you can write it is always t over 4. Some of you might think, why not 4t? Well, this is simple. We use 4t only when if we were to talk about, let's say, the population of trees in a forest growth 4 times in a year. So you have 4 times of growth. So let's say by 6% every 3 months. So the first 3 months you have 6% increase. Then after 3 months more you have 6% increase. Then you would write it as 4 times t. But in this case, because the increase is in every 4 years, we write it as t over 4. So that's going to be 14,000 times 0.94 to the power of t over 4. And that makes D the answer. Okay. Let's look at number 4. Which of the scatter plots shows the strongest positive association between x and y? So what is strong positive association? It's basically the association is how you associate, how you connect the x variable with y variable. If we have a strong connection, strong association, it means that the points would be closer to each other. They will be located close to each other. If they have a low or not that strong association, they will be farther apart, like in this case. As you see, we don't have the clear picture of what's happening between the variables. In this case, we have an association, positive association. In this case, we have a negative association. That's why the answer is not D. We would likely choose A as an answer, but if we look at C, we have the points that are very, very close to each other, and they are positively associated, meaning that if X variable is increasing, the Y variable is increasing as well. So we have an increase of X and Y, meaning they're directly proportional. That's why the C would be our correct answer. Let's move to another one. Jamie owes Tina some money and decided to pay her back in the following way. Tina receives $3 the first day, $6 the second day, $18 the third day, and $54. Okay, let's say this is the first day. She has $3. The second day she has $6. The third day, she has how many? $18. And the fourth day she has $54. Which of the following best describes the relationship between time and the total amount of money cumulative Tina has received from Jamie over the course of the 4 days? Well, we know that as Tina is receiving money, she's accumulating more, meaning that the amount of money that she has is increasing. That's why we don't choose D as an answer, because we have an exponential decay, but it's not a decay, it's actually increase. So is it linear or not? is the amount of money from the first to second to third installment the same? No. Why? Because the first time there was plus 3 increase. The next time it was plus 12. Then it was whatever that would be. So it is not increasing or decreasing linear because it is exponential, because the money that she's receiving is not constant. As we said, the first time she's earning 3, then 12, then whatever we have. So the answer is C. Albert has a large book collection. He decides to trade in 2 of his used books for 1 new book each month at a local bookstore. Which of the following best describes the relationship between time in a month and the total number of books in Albert's collection? Well, this is pretty easy. Look, he gives 2 old and gets 1 new. So basically we can understand that, well, if she has, let's say, 40 old books, what's happening with the number of books? Let's say that she has, well, let me write it like this. Let's say we have old books and then we have new books. He has, let's just not make 40 but 20. So he had 20 books. After he traded 2 of them for 1 new, then he traded 2 more for another one, meaning that now he has 2 where in cumulative numbers. Then he traded 2 more. He has 14 plus 3, then 12, 4, and etc. And if you add them, he had 19, now he has 18, now he has 17, 16. So basically what's happening is that he's constantly giving up 1 of his books. For the 2 units of books that he's getting 1 new, meaning that the amount of books that he has is decreasing at a constant rate. That's why the answer is B, decreasing linear. So the constant decrease. Let's look at number 7. A scientist counts 80 cells in a petri dish and finds that each one splits into 2 new cells every hour. He uses the function a of t, let me write that function, a of t is equal to cr to the power of t, to calculate the total number of cells in the petri dish after t hours. Which of the following assigns the correct values to c and r? So basically c in this case would be our initial value. Why? Because look at this here. If you remember, I've told you, if we have an exponential growth, if you have this number a, this is always the initial value. The r is rate. Whatever you have here in the brackets, this is rate. Okay. C is initial value and r is rate. Okay. And it says that he counts 80 cells in a petri dish. So the initial value of petri dish was 80 and finds that each one splits into 2 new cells. So the rate with which the cells are increasing are 2. Why? Because every hour there are 2 more, meaning that the first hour it is 2, the second hour is 4, the third hour is 8, 16, and etc. That's the rate with which it is increasing. So these are basically the exponents of number 2. Now let's take a look at number 8. Of the following scenarios, which one would result in a linear growth of the square footage of a store? Okay, so let's read one by one. The answer is obviously, as we have highlighted, underlined D. But let's look at A, B, C, and let's just cross them out and understand why they are not the answers. Let's look at A. The owner increases the square footage by 0.75 each year. So in this case, it is an exponential increase. Why? Because if we were to increase by 0.75% each year, it means that every year the 0.75% is calculated from the previous year, meaning that every year the increase is not constant. That's actually the definition of difference between linear and exponential growth. Because when we have a linear growth, for, let me write that, linear, for linear growth, the increase or decrease, whatever is that, so the increase or decrease is constant. It is not changing. We are either increasing whatever that we have or decreasing. Whereas for exponential, the increase or decrease is not constant, it's exponential. Okay, so that's why the A is not our answer. We're looking for a linear growth. The owner increases the square footage by 5% each year. This is the same thing. 5% each year is an exponential growth, because let's say that the first year it was 100, the second year it is 105, the third year is it's not just 105 plus 5, because 5% of 105 is a different number. That's why the answer is not B. Let's look at C. The owner expands the store by 5% of the original square footage each year. Well, the answer has to be C. I see. Maybe I made a mistake of choosing the answer D. Let's just take a look. The answer C says the owner expands the store by 5% of the original square footage each year. Yes, that is exactly our answer. So if the initial value was 100, well, not 100, let's say meters squared or feet squared, whatever, meters squared. So every year we have a 5% increase of base value, meaning of 100. 5% of 100 is 5. So the first year it is 100, the second year is 105, the third year it is 110, then 115, 120, 125, 130, and etc. That's why the answer is C. Now let's look at why D is not our answer. It says the owner alternates between adding 200 square feet one year and 300 square feet the next year. No, the linear growth, as it is stated here, has to be constant. That's why D is not our answer, because the answer D, it explicitly states that it alternates between 200 and 300, meaning that it is not constant. So the first time you have 200, the second time you have 300. So who knows what kind of increase that we have. Okay, so those were all the problems from the topic exponential versus linear growth.